Transport infrastructure projects are of essential importance for the European economy. Tunnelling projects are expected to generate some 800 million tons of excavated material over the next few years. Most of this material is currently going to landfill.
The Dragon project focuses on the use of tunnel excavation material, which is very essential as we have a lot of tunnels to be built in the European region. And for the moment, the law says that this tunnel excavation material is a waste. So to bring this waste back to the mineral resource, what it is in reality, we are focusing on this research project on the topic how to change the law, how to change the technique to be clear and sure that we can bring it to the industrial reuse, what we do not now for the moment.
A team of specialists has now set itself the task of facilitating the reuse and recycling of excavated material from tunnelling in an international research project funded by the EU. The Dragon project has developed a disc cutter load monitoring system to determine the rock properties. Dragon also involves the development of an integrated system which analyzes the excavation material directly on the tunnel boring machine and subsequently separates the high-value materials for further processing and reuse. The Dragon team has designed and built a pilot facility for this purpose. Here we show the steps involved in material preparation and sampling. The sample is passed to the feeder of the grain size analyzer provided by Haver and Burker. The animation shows the working principle of the grain size analyzer. The sampling unit now moves to elemental analysis, taking a second sample from the main material flow. Prior to elemental analysis, a jaw crusher reduces the sample material to a grain size suitable for measurement. Subsequently, the elemental analysis conveyor belt starts to move. A rotating cylinder compresses the material layer to the required thickness. The measurement process starts. First, the moisture content is determined. A capacitive proximity sensor shows the material presence, and the elemental analysis starts. The material is then passed to the Oxia unit, where the material analysis takes place. The data is updated immediately after analysis and displayed as X-ray fluorescence spectra, showing the number of elements contained in the sample. The test material is identified as sandstone. The entire project is covered by a life cycle assessment. The project team is currently working on the development of a raw material management system, which includes an exchange and trading platform. The aim is to offer materials excavated from tunnelling sites, here shown in blue, to companies from the minerals industry located in the vicinity, here shown in red. 2 of the 10 case studies for the Dragon project demonstrate typical industrial examples of producing concrete aggregates. The dry processing of Les Farrettes limestone enables the production of a good quality aggregate. Another example is the Nantes de Drance hydropower project in Switzerland. The excavated material is converted into 800,000 tons of aggregates, which are used for the production of concrete and shotcrete. The main crushing, washing, screening plant produces 150 tons per hour of aggregates. The 180 cubic meters an hour underground concrete batching plant covers the demand on site, including high-quality self-leveling concrete for backfilling. The Dragon project offers a range of benefits. Development of breakthrough technologies to secure innovation leadership for the European tunnelling and underground construction industry. Sustainable domestic supply of mineral resources within the EU by maximising the use and recycling of excavated materials, generating an estimated direct annual value of around 150 million euros. Sustainable reduction in environmental pollution, CO2 emissions and land use.